How do we solve an equation like cosine of 3x equals 0? So this is how my brain works. I don't know how to deal with the 3x, so I replace it with stuff. And I think about cosine in my head. And that is like the worst graph ever. Okay. And I know that cosine is going to equal 0 at a lot of places. So I start writing those places down. Do you know one of them?
Pi. And then pi divided by 2, and then 3 pi divided by 2, and then
yeah, 5 pi over 2, 7 pi. It's all the odd multiples of 2. And we can also go in the opposite direction as well. Okay, so cosine of stuff is going to be 0 when stuff is equal to pi over 2, 3 pi over 2, 5 pi over 2, et cetera, et cetera, et cetera. So keep this in the back of your head for when we get ready for it. Okay, so if I need to find critical points, I need to start by finding the first derivative. And so using the chain rule, derivative of sine is cosine, copy down stuff, multiply by stuff prime, which is just a, and I'm going to put that a out front. How does that feel?
Mm-hmm.
Okay, so now the question on the table is, when is a cosine of ax equal to 0? First step, divide both sides by a. And now we're sitting in this situation, right?
Yeah.
Also, f prime is always defined. Side note, right? Because it's a trig function, because it's a cosine function, not a trig function. Okay, so cosine of ax equals 0 when ax is equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, so on and so forth. So now we just divide everything by a. So cosine of ax will equal to 0 when x is equal to pi over 2a or 3 pi over 2a. Does this make sense?
Yeah. So then you would just take like you just find the minimum and maximum using the critical points?
Always.
Okay.
But first of all, we have an interval. And so I think the first the first strategy to kind of think about is how do we handle cosine of stuff equals 0? And then the second strategy is how do we handle a parameter? And then like, how do we compare that to our interval? So which of these values fit in the interval? And
3 pi divided by 2a.
okay, so what I'm going to do is I'm going to rewrite this interval as 2 times pi over a and 4 times pi over a. And I'm going to come over here and I'm going to rewrite these as some number times pi over a. So what's the number that's going to go here?
1/2.
Okay. And then 3/2 pi over a, right?
Yeah, and it'd be 5 seconds.
Yep. And the reason I did that is it's going to make it easier for me to compare. Now the pi over a is the same in both places. So now I just need to pick numbers that are between 2 and 4. So 3/2 is equal to 1.5. That's too small. What's 5/2?
Yeah, that's thin.
That one's good. What about 7/2?
3.5.
So that one's good too, right? But
Yeah.
if we did one more, what's 9/2?
4.5.
Too big, right? That's bigger than 4. Okay, so the critical points are these two values here.
Okay. And then you would just like take you would just substitute in a value to figure out if it's positive or negative at that within that range.
Did it tell you what test to use?
No, it just says list the critical points from smallest to largest on the interval.
Okay, I'm going to experiment here real quick. What's the second derivative?
Wouldn't just be a sine of x.
So we're going to have another chain rule. It's going to spit another a out front. And the derivative of cosine is negative sine.
Negative.
Yeah. But there's going to be two a's now.
Okay.
Okay. So the reason I'm doing this is because if you have a parameter, sometimes the second derivative test is way easier. Because notice what happens. So second derivative test says if my first derivative is 0 at the critical point, so I'm horizontal, then I can imply concavity. And if I'm concave down, then I must be sitting at a maximum. Whereas if my function has a horizontal tangent slope and then I apply concavity, I'm concave up, I must be sitting at a minimum. So that's the idea behind the second derivative test. And here's a case where it's really beautiful to use because those a's cancel out. And now I'm just asking myself, is sine of 5 pi over 2 positive or negative? And so if you're good with the unit circle, pi over 2 straight up and down, 3 pi over 2 is down here. So by the time I get to the next one, it'd be 5 pi over 2 would be straight up. So that would be equal to 1.
Yeah.
And so I just have negative a squared. And they told you a is greater than 0, right? In
Yeah.
the problem? Yeah. So then you know this thing is less than 0. So f is concave down. And so you are looking at a max.